Welcome to Sonic Sciences. Imagine the periodic table not as a static chart, but as a dynamic harmonic field. Each element a resonator in an invisible orchestra. Electrons form quantized shells resembling standing wave patterns bound by the same laws that govern harmonics in sound and vibration. Electrons exist in specific energy states, much like strings on an instrument vibrating at certain nodes. Shells and subshells act like harmonic layers, turning the atom into a multi-dimensional oscillator. Thus, the periodic table becomes a map of frequency patterns, with each element emitting a fundamental tone based on its configuration. Atomic number, ionization energy, radius, and electronegativity. Read musically. Groups become tonal families, sharing harmonic properties. Periods mimic octaves, repeating structures at higher frequencies. Transition elements function as modulation bridges, altering key signatures within chemical composition. This vision repositions chemistry within the sacred geometry of sound. Elements as active vibrational nodes in the harmonic web of reality. In 1865, John Newlands observed a peculiar musicality within the elements, arranged by increasing atomic weight. Every eighth element echoed the properties of the first, like the reappearance of a note one octave higher. He named this the law of octaves. Though initially mocked, Newlands may have stumbled upon a deeper truth. Elements resonate in cycles akin to musical scales. Patterns of chemical reactivity, valence, and behavior repeat, echoing the self-similar nature of harmonic intervals. Beyond atomic shells lies the world of molecules, where bonds breathe, oscillate, and vibrate in a symphony of thermodynamic motion. Infrared spectroscopy reveals this hidden soundscape. Each molecule has its own set of vibrational modes. When excited, they emit energy in patterns akin to musical overtones. Fundamental frequencies arise from basic bond vibrations, while overtones emerge as anharmonic deviations, mirroring the nuanced beauty of real musical instruments. Stretching modes parallel pure tones. Bending vibrations form harmonics. Complex molecular geometries resonate like polyphonic chords. So, Susan Alexander transformed abstract atomic data into sound by scaling Larmor frequencies, those associated with the precessional spin of atomic nuclei, into the audible range. She discovered that elements actually aligned with familiar musical notes. For example, hydrogen hums a subtle E, while phosphorus sings in C sharp. Carbon resonates with E again, and together these form harmonic intervals that are known in music as thirds and fifths. These tonal correspondences Well, they suggest that elements participate in a deeper harmonic system, one that we can perceive with both intuition and instrumentation. Though it's not a standard scientific term, the coefficient of mixability offers a really interesting conceptual key to understanding how substances combine. In a vibrational paradigm, it's basically a measure of how harmoniously two elements or compounds resonate together. When substances mix, their molecular vibrations have to align. Discordant frequencies repel, while harmonic alignments attract. Kind of like musical consonance versus dissonance. Entropy in this context becomes rhythmic diffusion. Enthalpy reflects energetic harmony or tension. And Gibbs free energy? Well, that acts as a harmonic compatibility score. Each atom is like a miniature cosmos, its nucleus serving as a gravitational anchor, and its electrons performing a layered dance of probability. These orbits are actually spherical harmonics, complex geometries encoded in mathematical wave functions. Electrons are governed by Schrödinger's wave equation. Orbitals correspond to eigenfunctions, which are basically quantized standing waves. When electrons transition between states, they emit photons, quantized packets of frequency. Every electron shift is, in a way, a note sounded in the cosmic organ. The atom is an instrument tuned by nature, struck by light and pulsing with information. In music theory, the circle of fifths shows how keys are related by perfect fifths, a 3:2 frequency ratio that's fundamental to harmonic structure. Similarly, Russell Smith's reimagined periodic table reveals patterns that mirror musical chords, triads, minor thirds, and perfect fifths. The transition from element to element, well, it kind of resembles harmonic progression. Entire periods function like ascending scales. Rows and groups interweave to create resonant geometries. Smith's periodic table becomes a musical mandala, an elemental circle of fifths, suggesting a universal architecture where resonance is the language of all order. If elements are notes, then compounds are chords. The way atoms bond, share electrons, and form molecules is, well, kind of analogous to musical composition. Some combinations are dissonant and unstable. Others create resonant, long-lasting structures. Chemical consonants. Consider water, hydrogen, and oxygen form a bent molecular geometry. The bond angles and dipole moment create a stable vibrating entity. Spectroscopically, it resonates with complex overtones. Larger organic molecules become full harmonic compositions, polyrhythmic, polyphonic, and interwoven. DNA is a double helix, not just by shape, but by vibrational design. The classic tabular form of the periodic table is convenient, but it actually kind of conceals harmonic relationships. Alternative layouts. Spirals, helices, toroidal structures better reflect vibrational and energetic truths. A spiral periodic table reveals the octave-like progression of electron shells. Toroidal models illustrate the self-referential symmetry of periodicity. Color-coded frequency mappings generate elemental music on paper. By reimagining the periodic table as a dynamic topology, a musical architecture of frequency fields, we unearth new ways to understand, manipulate, and reharmonize matter. This exploration is not merely metaphorical. Evidence from quantum physics, molecular spectroscopy, and harmonic theory suggests that reality is fundamentally resonant. From the subatomic to the celestial, structure follows vibration. Frequency is not the byproduct. It is the blueprint. Musical patterns in the periodic table are not anomalies. They are artifacts of a harmonic universe. Chemistry and sound are unified by ratios, resonance, and rhythm. To master the elements is to understand their song. To evolve science is to hear it anew. Thank you for spending time with Sonic Sciences. I encourage you to share this information with others who may appreciate this stream of thought. Thanks again and see you soon.